Alright guys, welcome to today's tutorial, and today we are going to be looking at the first shift theorem. So the first shift theorem states that the Laplace transform f of t is equal to f of s, then the Laplace transform of e raised to the power of a t f of t is equal to f of s minus a. Okay, so the same thing applicable. Let's say if Laplace transform of e raised to the power of minus at f of t, then the Laplace transform is what? Is f s plus a. So you notice that if the sign here is positive, then you are going to have s minus a, and if the sign here is negative, then you are going to have s plus a. So now let's see how true this is. Now you know that the Laplace transform f of t initially is what? Is the integral of what? Of e raised to the power of minus st f of t, right? F of t dt, isn't it? Let's call this one equation 1. Now let us now try to find the Laplace transform of, that is, f of t then e raised to the power of minus at, for example, and let's see what we are going to have. Now you will discover that this one will be equal to, that is integral of e raised to the power of minus st, right? Then multiply by e raised to the power of minus at f of t dt, isn't it? Okay, now look at something. If that is it, then we are going to have, if you evaluate this one further, it's going to be integral of e raised to the power of what? Of minus into, that is, s plus a raised to the power of t f of t dt, isn't it? Now call this one equation 2. Now if you compare equation 1 and equation 2 together, now if equation 1 says that the integral of e raised to the power of minus st f of t dt is equal to capital letter F of s, therefore the integral of e raised to the power of minus s plus a t f of t dt will now be equal to what? Will now be capital letter F s plus a. I hope you get that. So that is basically what this thing is all about. So we are going to do an example now so that you will be able to understand it very better. You are given that your f of t, let's say your f of t is equal to minus sine minus 3t sine 2t. Okay, so f of t is equal to e raised to the power of 3t sine 2t. Now the first thing you are going to do is that, first of all, you are going to find the Laplace transform of sine 2t. So you find the Laplace transform of sine 2t. So you find the Laplace transform sine 2t, don't forget, is equal to what? Is equal to 2 over s square plus 2 square. So which is equal to what? 2 over s square plus what? Plus 4. Okay, so then how do we evaluate this one with it? So don't forget that that formula says that f of s plus a, isn't it? So which means that in whatever you have, you understand, you are going to add a, and you check here that your a here for this one, your a is what? Is 3, right? So, and according to what we did earlier, what we proved earlier, now if it is e raised to the power of minus 3t, then you know that your a is going to be plus is going to be positive, and if it is a raised to the power of, let's say, plus a, then your a is going to be negative. So which means that the Laplace transform of e raised to the power of minus 3t sine 2t is equal to 2 over. Now here, instead of writing s, we are going to write s plus what? X plus 3 square plus what? Plus 4. That is it. Let's take another example so that you understand. Let's say f of t is equal to e raised to the power of minus, let's say, 4t. Let's put this one as plus, then cos 3t. Now, first of all, you need to find the Laplace transform of what? Of cos 3t. The Laplace transform of cos 3t is the same as s over s square plus 3 square, which is what? S over s square plus 9. Okay, so now when you get that, for you to now do for e raised to the power of plus 4, so if you know that your a here is now, your a is 4, so it's going to be what? It's going to be minus, so it's going to be, then your Laplace transform for e raised to the power of 4t cos 3t will be equal to what? Will be equal to, instead of writing only s here, you're going to have s minus 4 over, instead of writing s square, you're going to write s minus 4 square plus 9. So that is your answer. Of t is equal to e raised to the power of minus 8t cos bt. So first of all, you need to look for the Laplace transform of cos bt. Now the Laplace transform of cos bt is equal to what? Is equal to s over s square plus b square. That is the Laplace transform. So now if you follow the way, if you follow there's a video I did. I'm going to drop the link under this video, so I want you to go and watch it, so you will be able to understand how to differentiate, how to find the Laplace transform of cos. So the other one we did was for cos 80, so it's the same thing applicable to b also. So whichever value you are given, whether a, b, whatever, you can use it to solve it. So the next thing we are going to do is, since we've gotten the Laplace transform of cos bt, okay, and the shift theorem says that the Laplace transform of e raised to the power of minus 8t cos bt now will be equal to s. Instead of writing only s, it's going to be s plus a, because your a here is what? Is minus, so here is going to be plus over what? S plus a. You repeat the same thing, you square it, then plus what? Plus b square. So basically that is how to solve it. Let's take another example. We have the Laplace transform of e raised to the power of 8t then t raised to the power of n. So now you already know that the Laplace transform of t raised to the power of n is equal to what? N factorial over s raised to the power of n plus 1. Okay, so now therefore, according to shift theorem, the Laplace transform of e raised to the power of 8t t raised to the power of n will be equal to, now anywhere you see s, you are going to put s plus s minus a, because the a here, is what? Is plus, so you are going to put minus, so it's going to be n factorial over s minus a raised to the power of n plus 1. So that is on that. Let's go to another example. Now transform of f of t is equal to e raised to the power of minus t then cos t square. Okay, so now in order for you to get this one, so the Laplace transform will be minus then cos t square. So don't forget that in trigonometry that cos 2t is the same as 2 cos square t minus 1. Okay, so if you know that cos 2t is equal to 2 cos square t minus 1, then you can actually make cos square t is subject to formula. So cos square t will be equal to what? 2 cos square t will be equal to what? Will be equal to cos 2t plus 1. Therefore, cos square t will be equal to what? Will be equal to cos 2t plus 1 over 2. Okay, over 2. So the next thing you do is that instead of writing cos 2t, now the Laplace transform of cos square t will be the same as the Laplace transform of cos 2t plus 1 over 2. So now we have to find the Laplace transform of what? Of cos 2t plus 1 over 2. So you finding the Laplace transform of cos 2t plus 1 over 2 gives you the Laplace transform of cos square t. So in order for us to do that, we are going, first of all, we take out the constant, that's 1 over 2. We take it out into the Laplace transform of what? Of cos 2t plus 1 over. Okay, so that's 1 over 2 Laplace transform of cos 2t plus 1. So what you are going to do is that you are going to find the Laplace transform of each of these separately. So the Laplace transform of cos 2t, then plus the Laplace transform of what? Of 1. Okay, so now if you find the Laplace transform of cos 2t, you already know the Laplace transform of cos 2t is the same as s over s square, then plus 2 square, then plus the Laplace transform of 1. 1 is the constant, so if you are finding the Laplace transform of the constant value is 1 over s, that is that constant value over s. So you can put it in brackets. So you have 1 over 2 into s over s square plus what? Plus 4, then plus 1 over s. So what you do now here is that you can actually open the brackets. So if you open the bracket, you have s over 2 into s square plus 4, then plus 1 over 2s. Okay, so now if you have that, then you can actually see that you have, okay, s over 2 into x square plus 4 then plus 1 over 2s. So now, so the Laplace transform for cos square t now is the same as what? Cos square t is equal to what? Is equal to s over 2 s square plus 4 then plus 1 over 2s. Good. So don't forget that the original question said that we have to find the Laplace transform of e raised to the power of minus t cos square t. So using the first shift theorem, you now discover that your answer will be equal to, now instead of writing s, is going to be s plus 1, because here your value of k, your value of a here is what? Is minus 1, and it's going to be here as what? As 1, as plus 1. So it's going to be s plus 1, then 2 into what? Into s plus 1 square, this is square, yes, plus 1 square plus 4, close the bracket, then plus what? 1 over 2 into s plus 1. So that is for the first shift theorem. I hope you understand. Thank you very much for watching.